Okay, hello everyone. So I'm Dagimawi. My Capstone project is on application of Ensemble classifiers on bank marketing data. So as an introduction, marketing campaigns constitute a typical strategy to enhance business, and it's essential to optimize the marketing strategies. So this optimization is mainly driven by understanding customer behavior. So to do that, we can leverage data collected from marketing campaigns to derive insights from this data. So in this Capstone project, real-world marketing data is analyzed and modeled to predict the success of a campaign. And the main hypothesis of this work is that ensemble methods are better than individual classifiers for this task. I will explain the problem. So nowadays, marketing in banking service is one of the most crucial business tasks, and measuring the success of marketing campaigns helps to improve marketing strategies. So leveraging the data collected during campaigns can be of great use. So in this project, a real-world data set from a direct marketing campaign collected from Portuguese banking institution is used. The dataset contains client-related attributes, last contact information, and other additional attributes. Given these inputs, the problem is predicting whether the customer subscribes to a term deposit or not. So therefore, the problem can be formulated as a binary classification task. The main challenge related to this task is that attributes in the datasets might not be the only factors affecting whether a affecting the customer's decisions to subscribe to the term deposit or not. So this is the basic data exploration. Basically, the data contains 4,521 examples and it contains 16 attributes. From these attributes, the categorical attribute, some of them were categorical attributes and the others were numeric attributes. And the number of instances per class were like for class 0 or for customers who are not subscribed, there were who are subscribed, there were 521 examples, and for class 1 or not subscribed, there were 4,000 examples. So in the next part of the data exploration was checking the distribution of the features, the numeric features. So from this distribution plots, I have observed that most of the features have right skewed distribution. And from these distributions, I have observed that, for example, from the age attributes, I have observed that most customers have age 34. And from the campaign attributes, most customers were contacted once. And most of the customers are not contacted in previous campaigns, or they were contacted first time for this campaign. And the duration, most of the customer calls lasted about 2 minutes. And these are just basic data explorations. The next part of my explorative data analysis was based on some business questions, like from the data. I have come up with 7 basic questions that might be interesting for the bank itself. So these are basically assessing the number of customers subscribed or not subscribed, depending on the type of job, their marital status, educational status, their loan status, and the communication mechanism, whether it's telephone or cellular. And the next 2 questions were related to the calendar features, like which weekday has more subscribers and which month has the most subscribers. So to answer these questions, I have plotted summarized and plotted the data. For this, I have used bar chart and pie chart, and the conclusions. The conclusions were customers with management jobs represent majority of subscribed customers. And more than half of the subscribers were married. And based on the educational status of subscribed customers, 46% of them have secondary school educational status. So when it comes to data processing, I have done 3 basic data processing tasks. The first one was feature encoding. So there were lots of categorical attributes. So I had to encode these categorical attributes using one-hot encoding. And after feature encoding, the total number of features becomes 42. And as I have said before, there is a data imbalance. So to solve that problem, I have used syntactic minority oversampling technique. And after using this oversampling technique, the total number of instances were 6,388. And for train test split, I have used 80% of the data as training data and 20% as testing data. Now I will explain the models I have used. So for this project, I have compared, I have used ensemble methods and a normal regular support vector classifier. So for the baseline classifier, I have tested it with imbalanced input and balanced input. And the next was a boosting method-based classifier. For this, I have used gradient boosting classifier. And the third one was a bugging method-based classifier. And for this, I have used a random forest classifier. For the stacking-based method, I have used support vector classifier, random forest classifier as base models, and logistic regression as a meta model. And finally, for voting-based classifier, I have used logistic regression, support vector classifier, and random forest classifier with hard voting. So the overall process of training, tuning, and evaluation is summarized here. So given the input data, I have created a pipeline. So the pipeline, first the data is transformed using standard scalar, and then I have used dimensionality reduction. So the number of features was a little bit high, and correlation with the output variable was not that much for most of the features. So I had to use dimensionality reduction by keeping 95% of the variance within the data. And then I have used randomized grid search with 5-fold cross-validation to tune hyperparameters of different ensemble methods or the base learners with these ensemble methods. And finally, for evaluation, I have used 20% of the data. And for as evaluation metrics, I have used precision, recall, and F-score with macro averaged values. So these are the results from the evaluations. So based on these results, support vector machine with balanced input improved the F-score by 5% relative to the imbalanced input SCV support vector classifier with imbalanced input. And in terms of macro F1 square score, SCVC with imbalanced input improved the imbalanced version with support vector classifier, and support vector classifier with stacking classifier performed better than voting classifier, and support vector classification with imbalanced input. So this is the conclusion. So in this Capstone project, ensemble method-based classifiers are compared with individual support vector classifier with using a real-world bank marketing dataset. I have done exploratory data analysis and tested 4 ensemble methods. I have used 5-fold cross-validation with random search, randomized grid search to tune the hyperparameters. So based on the findings of this work, ensemble methods did not achieve expected performance when compared to regular support vector classifiers. One of the reasons might be related to the way I have done the hyperparameter tuning. Since I have used a randomized search-based method, the base hyperparameters might have been overlooked. And the hyperparameter search space is reasonably small due to the time limitation. Therefore, the base hyperparameter combination might not exist within the search space I have used. As a future work, I intend to continue this work by testing other combinations of classifiers with a hyperparameter tuning in large hyperparameter space. Thank you.